Hello, Algebra 2 folks, and welcome to Graphing Square Roots. Today you're going to need your graphing notebook or 3 pieces of graph paper, a writing utensil, and a calculator. And I just want to wish you a very happy square root day. Alright, so we are going to talk about some graphs we already know about. Y equals x squared, that's going to be a parabola, a U-shaped. Y equals absolute value x gives us a V for value. Y equals mx plus b is a line. And x cubed is a cubic function. It's kind of a roller coaster. It has n behavior and turns. And y equals x to the fourth power is quartic. And so that's going to give us maybe something that looks like this. Okay, so those are the graphs that we have learned, and we are going to continue learning graphs. And today we are going to spend our time talking about square root functions. All right, I'm going to make a table of values. -2, the square root of -2. Nope, can't graph i's. So we cannot take the square root of a negative number because that is a not real solution, or your calculator might say domain error. Okay, if I plug in a -1, the same thing is going to happen. And so what number can I start with, folks? Yep, that's it, 0. What is the square root of 0? Yes, it is 0. How about if I plug a 1 in there? What's the square root of 1? That would be 1. How about 2? The square root of 2 would be about 1.4 approximately. 3, I would get the square root of 3 is about 1.7. And 4, the square root of 4 would be, yep, that's a nice one, 2. And if I were to graph those points, my shape would look something like this: 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2. I'd make this nice curve and make an arrow going in one direction. And because we can't square root negative values, we have what's called this starting point. Now, I'm not sure if that's the technical name for it, but that's what I call it. It's my starting point. I can't go beyond my starting point in a square root. All right, and so now what is important about a square root function is not only that it has a starting point and that it curves and goes on for infinity in one direction, but that we cannot take negative values and square root them. So just remember that we can't put negative values underneath the radical when we have an index of 2. Also, we need to discuss some domain and range. Now, if you know your starting point, that's really going to help you with your domain and range. So my domain has to do with my x values, and my range has to do with my y values. So if I look at my x value, my starting point is 0. What's happening to the graph beyond 0? The values are getting bigger. So my domain would be x such that x is greater than or equal to 0. Now we do the same thing with our y values. We start at our starting point and see what happens to our y's. They're getting bigger. So it's y such that y is greater than or equal to, yep, 0 again. Not sure why I wrote a 2 there. I apologize for that. I'm going to erase it. Make sure I write a 0 there because my values are getting bigger than 0. All right, that's the parent function. Remember when we had parabolas and we shifted them, or the absolute values and we shifted them? Well, we're going to talk about the same kind of thing here. What happens to this parabola? What's happening to this parabola? Well, nothing. The vertex, remember, it was based on the vertex, would stay at 0, 0 because there was no shifting here. What happens to this graph? The new vertex, instead of it being the parent and going through 0, 0, this one would be 0, negative 8 because it's moving down 8. This one is still at 0, 0, but it's reflecting. So it's making the graph go down because instead of the graph being an upright U, it was a U shape that went down. So it was a reflection. This said x plus 6 to the squared, and that said we would change the graph horizontally. So this would move the graph left 6. Remember how we said that would move the graph left 6? Okay, what would happen to this graph? What happened to the vertex of this graph? The vertex of this graph would have been 4, 5, because it went right 4 and up 5. Now what happened with that? Well, that really doesn't change the vertex, but it did change the look of the graph. Remember that compresses the graph or widens it by a half, so it makes it wider. Okay, the same sort of thing happens today with square roots. If I'm given the general graph y equals, okay, the square root, and I change the parent, and I add a k to the end, that means the graph is going to have a vertical shift up or down. The h is going to cause the graph to move left or right. The a out in front will make the graph either stretch or compress. And finally, the negative out in front will cause the graph to have a reflection. Okay, so these ideas do not change even though I'm now talking about a totally different graph. All right, so let's do a couple of graphing and see how the shifting and everything comes together. So I'm going to be graphing and making this table. It's g of x equals the square root of x minus 3 plus 4. Now remember, those are my starting values or how my graph is shifting. So if I'm going to talk about how my graph is shifting here, my graph is shifting right 3 and up 4. So my starting point on this graph is 3, 4. So when I plot 3, 4, I'm either going to go in one direction or another, but this is my starting point, and I can't go through that point. Okay, now, what kind of values can I graph or take the square root of? Well, they have to be greater than 3 because we can't have any negatives. If I put a 2 here, I would get 2 minus 3 is negative 1. Negative square roots don't work. So the next value that I'm going to take the square root of is 4. So I'm going to say the square root of 4 minus 3 plus 4. The square root of 4 minus 3 is 1. The square root of 1 is 1. And 1 plus 4 is 5. Okay, now I'm going to plug a 5 in there. When I do that, 5 minus 3, well, that gives me 2. The square root of 2, remember, is 1.4. And so if I take 1.4 plus 4, I'm going to roughly get 5.4. The next number I'm going to use is 6. 6 minus 3, well, that's 3. The square root of 3 is 1.7. 1.7 plus 4 is roughly 5.7. I'm going to do one more. I'm going to go ahead and plug in 7. 7 minus 3 is 4. I'm going to take the square root of 4, which is 2, and 2 plus 4 is 6. Okay, now we're going to take these points and we're going to graph them. 3, 4 was our starting point. 4, 5. Okay, so here's the direction. I'm going to be going in this towards the right. So 4, 5. 5 and 5.4. 6 and 5.7. And 7 and 6. And I got this nice curved shape graph. Remember, nobody goes past the starting point. Okay, now the starting point always helps us with domain and range. So it started with 3. What happened after that? Well, all those values got bigger. So it's x such that x is greater than or equal to 3. Same thing with the y's. They kept getting bigger. So it's y such that y is greater than or equal to 4. Okay, let's try one more. Here we've got g of x equals negative x plus 1 to the 1/2 power. Remember, this just all means the square root. Remember, we don't want to lose that knowledge that we've gained, that when we do a power to a 1/2, we still have a square root. All right, so let's talk about the starting values of this graph. We're going to go left 1 and down 2. Those are going to be my starting points. Okay, this graph has a reflection, so be careful that we don't graph going up because it's going to reflect, which means it's going to start and go down. Okay, so let's plug some values in here. What values can I plug in again? Well, I can start at -1, and my values are going to probably have to get bigger. Let's see. 0. 0 plus 1 is 1. The square root of 1 is 1. Bring over the negative. That's -1 minus 2. That equals -3. All right. Sorry about that. Let's keep going. Let's plug a 1 in there. 1 plus 1 is 2. So I'm going to take negative square root of 2 minus 2. The square root of 2 is 1.4. So this is negative 1.4. Don't forget to bring that negative over. Minus 2, which would be negative 3.4. Okay, let's plug in a 2. 2. Negative square root of 2 plus 1 is 3. The square root of 3 is 1.7, but again, bring that negative over. We got negative 1.7 minus 2, which would be negative 3.7. Let's go ahead and plug in 3. 3 plus 1 is 4. Oh, that's a nice number. The square root of 4 is 2. Bring that negative over. Negative 2 minus 2 is negative 4. Plot those points. -1, -2, 0, -3. Look at how this graph is going down because it's a reflection. 2, -3.7, and 3, -4. Now be careful because this should be a little bit more curved than what I'm showing there. I didn't graph them very nicely there. It should be a nice curve. It should not be a straight line. This is our starting point. Remember, we cannot go beyond our starting point. Now if we look at the domain and the range, I started at -1. My values got bigger. The domain is x such that x is greater than -1. I started with -2 with my y, but my graph got smaller. My y's got smaller. So this would be y such that y is less than or equal to -2. Okay, folks, that's all I've got, and we'll see you soon.